Hello students, so now we are going to start with the first problem, which is based on properties and definition of Jacobian. I'm sure that you have watched my previous video because there I have covered the concept and the formula which will be requiring to solve this numerical. So if you have not covered it, I would request all the students to go back and just revise that concept again and then come back to this question. So here I'm going to solve this question with the help of Jacobian. So let's see. So guys, here the value of x and y is given. So x is given as a hyperbolic cos u into cos v, y is given as a hyperbolic sin u into sin v. So if you observe, then x and y is given as a function of u and v. And what we have to do is we have to find out del xy by del uv, that is partial differentiation of xy with respect to uv. And guys, we have to show that this value is equal to this. So how to do that? So it's very simple, that we have to use the Jacobian definition. So here I'll be using the definition of Jacobian to get the answer. Now the question is, what is the definition of Jacobian? So here I'll show you. So guys, this is a definition of Jacobian which we have seen in the previous video. So guys, to get the answer of this question, I need to find out these four unknowns. So first I'll find out del x by del u and del x by del v, and for that I'll differentiate this x with respect to u and v partially. So let's see what we get. So here, by differentiating this with respect to x partially, we'll get del x by del u as, so guys, we know the rule that whenever we do the partial differentiation with respect to some variable, that time we assume other variables as constant. So in this case, now we have u, v and a. So since I am differentiating with respect to u, the v and a is constant, so we'll get a into cos v outside. And now we'll differentiate only hyperbolic cos u. So the derivative of hyperbolic cos u with respect to u is hyperbolic sin u. So this is the answer. Now let's find out the other value, that is the value of del x by del v. So for that I'll differentiate this function again with respect to v. So now a and hyperbolic cos u are constant. Now I'll differentiate cos v with respect to v, so we'll get negative sine of v. So guys, these are the two values. Now we'll find out next two values, and for that I'll differentiate y with respect to u and v respectively. So let's see what we get. So if I differentiate y with respect to u, we'll get a sin v constant, and for sin hu, or it is called as hyperbolic sin u, we will get answer as hyperbolic cos u. So next guys, we'll find out the value of del y by del v, and for that I'll differentiate this y with respect to v partially. So guys, now a and hyperbolic sin u are the constants. For sin v, we'll get derivative as cos v. So this is the answer. Now guys, as we got all four values, we'll put all these values here in the determinant to get the final answer. So we'll write here. Now guys, we'll solve this determinant, and we know the rule to solve the determinant. So in this, what we do, we first multiply the elements on the primary element, primary diagonal. So here I'll multiply these two elements, and then we'll subtract the multiplication of these two elements. So we'll get then middle sign minus and multiplication of these two, so that is a negative, so that will become plus, and that is. Now guys, to get the answer, if you observe here, then we want hyperbolic cos to u and cos to v as a final answer. But in our solution, if you observe, then here we got the sine term as well. So to get the cos term, what I'll do is I'll convert all terms into cos, and for that I'll use few formulae. So for hyperbolic sine, we have one formula, I'll show it here. So guys, this is the formula in hyperbola. So hyperbolic function. So according to this formula, if I want to find out the value of hyperbolic sine square u, then that is hyperbolic cos square u minus 1. So here I'll say it is. Similarly, here sine square v is 1 minus cos square v, so we'll get. Now guys, from these two terms we can take a square common. and we'll multiply this bracket with cos square v. So we'll get hyperbolic cos square u into this and minus of this. So next, if I multiply this bracket with hyperbolic cos square u, we'll get. Now guys, after this, if you observe, then these two terms are exactly same and opposite in sign. So I can cancel these two terms. So we will get here a square and these two terms. But now guys, this term are the square terms. But if you observe the answer, then in the answer we want hyperbolic cos 2u and cos 2v. So for that, we'll use the formula for this. So for hyperbolic cos square u, we have a formula hyperbolic cos 2u plus 1 by 2. Then middle sign is minus, and for this we have a formula 1 plus cos 2v upon 2. Now guys, from these two terms I can take 2 common, so that will be a square by 2 outside. Next, due to the negative sign, this will become minus 1, and that is why I can cancel this plus 1 with the minus 1, and from here we will get hyperbolic cos 2u minus cos of 2v. And guys, if you observe, then we got the exact answer. So here we have proved the result with the help of definition of Jacobian. So I am sure you understood this video. So guys, keep watching the videos, because in the next video I am gonna cover few more numericals on Jacobians. And don't forget to share this video with your friends, because if they have any doubt in the Jacobians, they can also get such a nice explanation. Thank you very much.